All right. I remember in the last class, I discussed a problem. The problem is about like if a number divided by 3, the remainder is 1, and if it's divided by 4, the remainder is 2. What is that? What is the smallest number satisfying this condition? Now we did a it's a very specific problem. So there was a 5th grade student in my class, and he generalized this theorem, this problem to more general case, and he solved the problem. It looks like a theorem. Okay, this is the problem he generalized. Okay, so if a number, yeah, this yeah, let's see. Okay, who is the okay, Alex Chen, you want to record it? Okay, good. Can you make the message a little larger? All right, I'm going to discuss the problem. Last time we did it. All right, this is a problem about if a number divided by 3, the remainder is 1, and divided by 4, the remainder is 2. So what is the smallest possible integer has this property? So now I'm going to record that problem. Okay, it's interesting. Okay, this is a problem. Okay. What is the least positive integer that had a remainder 1 when divided by, now the original problem says divided by 3. I'm going to say divided by p, okay? P is the integer, okay? Is a remainder of 2 when divided by p plus 1, okay? Here, where p is a positive integer, okay? Now, the problem I discussed is, p is going to be 3, so p plus 1 is 4. So there was a student in my class, he said, oh, let's try to change 3 to p, then 4 is p plus 1. I'm going to find the least positive integer, and he found out it's p squared plus 1, and I look at it's great. Okay, so how do we solve this problem? Right, now we're trying to find out. Okay, the answer will be p squared plus 1. Okay, why p squared plus 1 satisfies those two conditions? And this is the smallest one. There are other solutions. Okay. So he gives a problem to him. He solved the problem. Okay, so let's see. How do we find such integer? Okay, so this integer divided by p has remained 1. So you have p cubed plus 1, right? Now the second condition says if it's divided by p plus 1. Now, if you divide by a larger number, the quotient cannot be the same q. If it's q, because the remainder is here is 2, right? So this number q must be, this must be smaller than original q. So let's say q minus 1 or q minus 1. So this p cannot be, this m cannot be larger than 1. No, sorry. So this quotient must be less than q. So be q minus 1, q minus 2, q minus 3. So let's subtract m there. So this is the identity. Now, the reason is because the remainder is 2. If you put the q there, then this will be the number larger than the previous one, right? So it's p, the same number, right? So let's take a look at the difference of those two numbers, okay? So then pq plus 1 equals p plus 1 times n minus q, okay, n plus 2. Let's multiply this out, and let's see what we can get, okay? We will get PQ, I'm going, yeah, PQ, P plus, let's see. P plus 1 times Q, and P plus 1 times M, and plus 2. So we're going to get rid of a P times Q, right? So I'm going to get rid of that. All right. So what I can get is I find the Q, I move the other term to the left-hand side, and it's minus 1. Okay. So minus 1. Okay. Now look at this Q. Okay. So here M could be 1, 2, 3, right? Okay. This is the most M. So when M is greater than N max be greater than 1, so this definitely is greater than P plus 1 times 1 minus 1 is P. Okay, so this Q cannot be smaller than P. The smallest value you can get is for P. Is P. All right, let's put it back. Okay, so let's put it back. So the general form for N is N times Q, P plus 1 M. Minus 1 plus 1. So here M equals 1, 2. And the smallest number will be P, and this part is already greater than equal to, right? So it will be P plus 1, which is P squared plus 1. So this is the answer. Okay. So this is the answer. Okay, we find the smallest one, and we also find the general formula satisfies those two conditions. It's a P squared plus 1. Yeah. I'm surprised that he solved this problem in the general case. Okay. Yeah, we are going to, folks, today's lesson is still on the numbers, and there will be about equations. So my first problem I'm going to discuss, yeah, the next problem to discuss is the following. We consider, yeah, the smaller of two consecutive integers is added to the numerator and the smaller one is added to the numerator, and the larger one is added to the denominator of the fraction 5/7. What must be the integer b if the resulting fraction is equal to 4/5? So what's the question? We're going to find the two consecutive integers. So here's the idea. Okay, we have 5/7. That's a fraction, given the fraction. Okay, and we are going to add two consecutive integers. The smaller one is going to be added to the numerator. Okay, the larger one is added to the denominator. Okay, so this will be a new fraction, which is 4/5, and find the n. Yeah. So given given this fraction, I'm going to add two consecutive numbers, one to the numerator, one to the denominator. And I get a new fraction. That new fraction is going to be 4 over 5. So this is just an equation. So you solve the linear equation. You multiply this out, you will get 5 plus n equals 4, and 7, this is 8, right? 8 plus n, okay? Then you multiply this out, it's 25 plus 5n, and equals 32 plus 4n, okay? The final result will be n is going to be, 32 minus 25 is 7. Yeah, so you add 7 to the numerator and 8 to the denominator, then you get, after simplifying, you get a 4 over 5. So those just solving the equations. I'm not very interesting. I'm going to do the next one. Yeah, the next problem, I think we probably did it before, is if you have a integer n and m, okay? Another one is n plus n minus p, n minus p, okay? So we assume that, here's the assumption, n is greater than m, and it's also greater than p, so n minus p will be positive. So my question is, which is larger? Okay, now we did that similar problems before. Now I want to, you subtract the numerator and denominator, right? And then by a same number, you still get a positive numerator and a positive denominator. After you simplify, right? And you get a new fraction. Now, are you going to get a larger one, or are you getting a smaller one? Okay? So to answer this question, you take the difference. Okay? And then you simplify to see if you are able to get some conclusion. So here's m minus p, and n times n minus p minus m n minus p. Right? Let's simplify it. The numerator is nm minus mp minus nm plus mp. Okay. So mm is gone. Then you take the common factor out. So by assumption, m is smaller than n, so the numerator is smaller. Okay, so numerator is smaller, is negative, right? Because m is less than n. So now you always have this inequality. So if the numerator is larger than the denominator, every time when you subtract the same number from numerator and denominator, you decrease the value. Okay, and then sometimes it's harder to see that. Sometimes like a 1, 2, 3, 4, 5, 6, 7, 8, for example, right? And something like that 1, 2, 3, 4, 5, 6, 7, 7, right? And this, I'm pretty sure it's after you subtract the 2 and from each. Otherwise, it's harder to compare. If you subtract the 2, and then now, because the numerator is larger than the denominator, and you subtract 2 from both sides, from numerator and denominator, and you increase the value. You increase the value according to the above computation. All right, so today we're going to solve focus on equations. We are given 27 to m equals 3, and m to the power n equals 81. Find the value m times n. Okay, find the value m times n. Right? Are you working on the problems? Okay, so let's look at this problem. Okay, so you have to step by step, right? Find, you're going to determine m and n. Okay, so to compare both sides to determine the value of m, we need some formulas, right? First of all, we should know that 27 is going to be 3 cubed. Okay, so 27m is going to be 3 cubed to the power m, which is 3 to the 3m equals 3. So this implies 3m equals 1, and it implies m equals 1/3. Okay, so after you find 1/3, you plug into the second equation. Okay, and then you have to, so this is going to be 1/3 is 3 to the -1, so 3 to the -n, and 8 is going to be 3 to the 4th power. Okay, so from here, -n equals 4, and n equals -4. So you multiply this out, you get one number, okay, which is -4/3. Okay. Now, our next problem is also an equation, but be careful, only one equation, but you have 2 unknowns, okay? So the sum of the reciprocal of 2 consecutive integers, okay, positive integers. So actually, we have only one variables here, because 2 consecutive integers is going to be, that only depends on the first one. Right? Find the sum of those 2 integers. Okay, so this is you will get an equation. You write down the equation and you try to solve it as quick as possible. Yeah, if we so the idea, conduct the integer, the first one denoted by n, right? The second one will be n plus 1. It's 7/12. What is the best quick way to solve? for n. I think, yeah, this will be n plus 1, and n plus 1 plus n will be 2n plus 1, which is 7 over 12. Okay, I think as the best, as a quick way to solve this problem would be just try and guess and try. The reason is that 12 is going to be 3 times 4, right? And you look at that, the denominator here, n times n plus 1, so which will be, you know, if it's 3 plus 3, yeah, if n is 2, if n is 3, then you can quickly get the answer, okay? So you will get the answer right away. But if you don't see that, it takes much more time. If you don't see this, then it takes much more time. You have to solve this this equality, right? Then you get a quadratic equation, and you have to use the quadratic formula. It's really complicated, honestly. Okay, so you will get 7n squared, right? And this side is 24n plus 24, 7n squared plus 7n, and after simplified, you will get like a 17 minus 12 because you see, and it's very hard to find the roots. You have to use the quadratic formula, but eventually you will get n equals 3, but that takes much longer time. Okay, is use the quadratic formula, you will get 2 times 7 and 17 plus minus 17 squared minus 4ac. And you will, after you simplify, is 17 plus minus 25 over 14. So you are going to get one positive number, another negative number. Positive number is a fraction, is an integer, okay? So when you choose a positive sign, you will get 3. Another number will be 4 over 7. So this will be done, but that's not the right way. It works out, yeah, eventually it works out, but it's not the right way to solve the problem. Okay. So so when you get a question, don't be in a hurry, just multiply them out. You have to look at whether this is a very special equation or not. Sometimes you can get the solution quickly, right? So my next problem is going to be find the of ordered pairs of integers n and m. Okay, so we here we have assumption 1 is less than or equal to m less than n. Okay, such that n times m equals 34. That's the equation, right? That because they're integers, so you don't have so many solutions. Okay, this is an easy problem. Please do this problem. So I have 3 Eric in this class. Eric Gu, Eric Shen, no, Eric Wang. All right, are you done with the problem? Just trying to find all the possible factors of 34. Okay, 34, right, can be written as 1 times 34, and then divide by 2, it's even number 2 times. But 17 is already a prime. 17 is already a prime number. You cannot make a further factoring. Yeah. So there'll be only 2 solutions: 1 34 and 2 17. Okay. It's not complicated. The next one is a little bit different. Let n and m be 2 natural numbers, which means 1, 2, 3, 4, 5. Okay. I know the product of their sum and their difference is 60. Find n. Right? Find the n and the m. I hope there's a unique solution here. Find the n and m. How do you solve this problem? Okay, you have 2 integers, but only 1 equation, right? Equation, the product of their sum and the difference will be 60. So write down the sum. Write down their difference. That's going to be 60. Okay? Are you able to do this problem? Yeah, try this first. Yeah, maybe you can find some special solutions. Okay, maybe you find some special solutions. But 60 is so special. See, 6 is written as product 2 numbers. What are the possible products you're going to get? Okay, 60 can be, let's factor 60. 60 is 2 squared times 3 times 5, I think. Okay. Yeah. So this is prime factorization. And you have to write down the possible combinations. We suppose, yeah, think about that. Suppose m equals p. Now suppose it equals p times q, right? And n plus m, n minus is good q. Okay? But when you add them together, p plus q should be even. Okay? So that's a key point. So this implies 2n equals p plus q must be even. So that gives you some information when you express the 2 possible factors. It cannot be 4 times 15 because 4 times 15, if you add them together, it's not going to be even. Either both are even or both are odd. Right? Cannot be 1 even, 1 odd. So this implies both q are even or both q are odd. Okay? So that gives you only few possibilities to write down 60 as a product 2 numbers. Okay. Okay? So you cannot say 60 is 1 times 60. You cannot say 60, no, but you can say 60 is going to be 2 times 30, right? That's okay. And I think that cannot be 4 times 15 because 4 times 10 wins odd, wins even. That both must be even or both must be odd. I think this is the only choice. Yeah. This is the only choice. Yeah. Otherwise, you have so many possibilities. You have to try one by one. So we know ahead of time the sum of the two factors cannot be must be even. So then that gives you more restriction on the factors. Okay, so it's 2. So I think the first one will be n minus m is going to be 30, n minus m is going to be 2, and add them together. 2n is going to be 32, n is going to be 16. Right? Then m is going to be 14. Right? 14 and 16. So that's the answer. Okay, that's the only answer you can get. All right, so the next problem is a little bit tricky. 2 positive integers n and m satisfies the product, okay, and find the n and m. Okay, I will give you this problem for a try. I'm not going to work out for you. Okay, Brian, I will wait for your answers. Don't talk. The two numbers here, right? Only one equation. Are we able to solve it? I will call your name, okay? I have a list of our names, almost. Some of you didn't even put a name here. I know Kelly didn't. You didn't even write your name. I know you. Andy, did you solve the problem? Sophia, you have answers? Michelle? Not yet?
N equals 17, M equals 16. There you go. That actually does work.
Yeah.
Yeah, that works.
That works, right? All right. One equation, two numbers. Of course, in general, you cannot solve it. But this is a very special equation. 17 is a prime number. So only way you can express 17 as a product would be 1 times 17, or 17 times 1, right? Or 17 times 1. And n minus m is smaller. So n equals 17, n minus m equals 1. So this implies m equals 16. Very simple. That's it. Okay. So the next problem is the sum of 3. Sorry, let me erase it. The sum of three consecutive integers, other integers 45. Be careful. What is the greatest of these numbers? Okay. Yeah. So the sum of three consecutive other numbers is 45. What is the greatest of these integers?
16.
Let's see, right? So three consecutive integers you have to write in this form. Okay, there's a gap, okay, between two consecutive integers will be 2, not 1. So the sum will be 3n equals 45. That n equals, the n equals 15. So the largest one, n plus 2, is 17, not 16. Because there's three consecutive other integers. Okay, not three consecutive integers. Right? Not consecutive integers. Consecutive other integers. Okay. My next question is I will read the problem for carefully. So the sum of three integers is 484. The two smaller are consecutive integers, and two larger ones are consecutive other integers. Find all those numbers. Okay. The sum of three integers is 484. Okay. The two smaller ones are consecutive integers. And the two larger ones right? Find these integers. Right, so you have three integers, two smaller one consecutive integers, the two larger one. Yes. Yeah, the two larger ones are consecutive other integers. Okay. So you can label them in the order, right? So what they do is they just n minus 1 n, right? The other one should be n plus 2. Okay, I'm pretty sure n is going to be the other integer, n, right? So this is you have to express in that form, add them together. So will be 3n plus 1 is going to be 484. So 3n equals 483. And let's divide by divide by it's going to be 100. Then n is going to be 483. 3, right? 1. So 161. So you find 161, then you add 1, add 2, you get another one, right? So those are the straightforward problems. The next one is Slightly similar form, but slightly different. Okay. So A, B, C, D, E are consecutive integers. Okay. And we know that if B plus C plus D equals 39, find the value A plus B plus C plus D plus E. Yeah, I have a five consecutive integers. If B plus C plus D is going to be 39, what, the one in the middle, right? And what find the sum of all the integers? Hmm? What do you get? All right, so consecutive integer, you have to use this property, otherwise you cannot solve it, right? So consecutive integers, the one in the middle is n, right? Then the one before that, the n minus 1. The one after that is n plus 1, right? And add them together, then the one before that, n minus 2, then n plus 2. So the sum of those five integers will be just 5n. The sum of the three integers will be 3n, right? So it would be 3n equals 39 implies n equals 13. Yeah. Right? So then the sum of the five consecutive integers will be 5n. So 5 times 13 yeah. 5 times 13 is 65. Right? Yeah. So once you determine once you determine the middle integer, you can get the rest of them. That's a key point. All right, so we have lots of questions about consecutive integers. All right, the next one is not a consecutive integers. And the next one is a question. Okay, what is okay, what positive integers are 56 less than its square? Okay, so you may have many solutions, maybe just only have one. So write down the equation based on the given information and you try to solve it. Yeah, please write down the equation and try to solve it. Hmm? 8. Yeah. Karen, do you have answer? Yeah. So then integer we can call n, right? Which is 56 less than its square. So just write down this equation. Then you get a quadratic equation. Okay. Now you can use a quadratic formula to find the n. Some students may be able to fact it. Okay. If we are able to fact it, that'll be n minus 8, n plus 7, because 7 times 8 is 56. So this implies n equals 8 because n cannot be negative. So those are the positive integers. So the answer will be n. Okay. Negative 7 also has this property, but it is not going to be positive. It is not positive number, so it's not the solution. Okay. My next question is, I wanted to do that. So find the, oops. Yeah, touch the button here. So find the, find the number such that the following is true. So for what number? What the value of n does the following hold? Okay. So this is this is sum of n integers, right? So it equals 153. Okay. Okay, can you do this? Can you determine the integer n so that the sum of the integers from 1 to n is going to be 153? Okay, I'm going to slow down a bit, okay? So you will get equation. Now this is already equation. You have simplified the equation. You have so many terms here. 1, 2, right? 1, 2, 3, all the way to 10. Okay. You cannot by guessing try, it's harder to get. Right? Are you doing the problem? Hmm? 17? Okay. Yeah, first of all, you have to record the formula for this sum. It's n plus 1 divided by 2 equals 153. Then you will face the problem whether you are going to multiply this out to get a quadratic equation, or you can fact it. Okay, so when 153, I think I can fact it. The reason is this is a divisible by 3. Make a quick observation. 1 plus 5 plus 3 is going to be 9. 9 is divisible by 9, right? So it is divisible by 9. After you divide by 9, you will get 17. Then you find out 2 times 9 is going to be 18. So it's 17 times 18. So if you're able to see that, then the answer would be simple. N is going to be 17. Otherwise, you have to use quadratic formula to solve this quadratic equation. You see? Yeah, how do I factor the number quickly? Just because 153 is divisible by 9. I know that, right? 8 is a coefficient, 8 is a digits together, it could be 9. Then I divide by 9, I get 17. I know 17 is a prime number, so I can quickly factor this number, 153. Then you're trying to express 2 times 153 as the product of 2 consecutive numbers. And it's obvious now, 17 times 18. Then you solve the problem. Right? Right. So the next problem is going to be the number 2297, 295 is the product of several consecutive integers What is the greatest of these numbers? Hmm? Several, yeah. So that means you have to factor this number to the product of several consecutive integers. Now, is there any way you can factor this number? How to do that step by step? Do you have a calculator?
Yeah.
You can use a calculator.
Okay.
Right.
What is 1 plus 1? 2. No.
We recall all the theorems we already have, right? A number is divisible by 9 if only of the digits, the sum of the digits is going to be divided by 9. So you look at that, if a number is divisible by 3, if and only if the sum of the digits is divided by 3. So I'm going to also bring my calculator. So let's show you how do we step by step to factor the number, okay? So I look at that, I see 2 plus 2 plus 9 plus 2 plus 7 plus 9 plus 5. I don't know what about this 9s maybe, because there's a multiple 9. So this will be 9, right? And 2 plus 2 and 5 are also 9. So this is a divisible by 9, right? So then you can divide this number by 9, right? So let's see, 2297, 295 divided by 9, you will get a small number, 255, 255. Now, 255, 255 is a really good number. You can factor it, okay? Right, right? 255, 255. Because 255, yeah. it's also divisible by 3 because 2 plus 5 plus 5 is 12. 12 plus 20, it's also divided by 3. But I think maybe we can 255 times 255 is going to be, sorry. Sorry. So you will have this, right? You take 255 out, you get 1001. Right? Then you can continue to fact it. But if you don't see that, and the 255 is divisible by 3, right? So divided by 3, it's going to be is going to be 85085. Okay. Now 850850. This is no longer divisible by 3. But since this end up with a 5, it's divisible by 5. So you can divide by 5 first. Right? So this is going to be 5 times 17017. Right? But then 17017, and clearly it's divisible by 17. Right? So you divide by 17. Okay. Now the question is how can I factor 1001? Okay. And we don't have much. You see, it's not divisible by 3. It's not divisible by 5. But try and divide by 11 because we already learned that, right? 11 is alternating sum will be 0. I think alternating sum will be divided by 11. So this is a divisible by 11. You see that alternating sum is 0. So it's divisible by 11. 1 minus 0 plus 0 minus 1. It's just 0. So then you divide by 11 and you get a much smaller number. Right? So then it's a small number, right? Okay, and so you already use, this number is now going to be by 11. So you look at this, which now 90, right? I think 7 times,
13.
yeah, 7 times 13. Now this is a little, actually the most hard part is 91, factor 91. So you have to try several numbers. Some students remember that. So divide by 7 is going to be 13. So it's 9 times 3 times 5 times 17 times 11 and times 13 times 7. So now you have a pretty good idea to write down the sequence of all prime or other consecutive other numbers. Okay, consecutive other numbers. So what you can get? Okay, you begin with, I think I begin with a 7. 7 is the smallest number, and then 9, and then 11, then 13. 15 is 3 times 5, and the 17 is the largest number. So this is a another way to do is because you already know it's going to be the product of consecutive other numbers. So 17 hasn't shown up yet, right? So 13. So use a 13. You can also quickly factor the 91. Okay. So I'm not sure 7 should be there, but the 13 at least should be between 9 and 17. So between 11 and 17. 13 must be there. I already get 17, I already get 11, right? So it's a product of consecutive with other integers. So I'm pretty sure 13 should be there. So use 13, then divide 91 by 13, you get 7. So this way, every step you have to find the possible factors to use it, okay, to divide it. Then you step by step you get the answers. Okay. All right, my last question, not last question. Let's look at the page numbers, the digits used. Do you remember the formula? How many digits can be used for book page with page number between 100 and 999? Okay, so we have a book, okay, has n pages, okay, and n is between 100 and 999. Okay, my question is, how many digits are used to number the book, the numbers of pages? Okay, and that's the first question. The second question we want to know is that's the first question. Let's figure it out. Okay, a book has n pages. The page number is going to be between 100 and 999. How many digits do we use? For example, 23, we use 2 digits, 2 and 3. 9 is just only when you use 1 digit, right? Page 1, page 9. How many digits do you use? 9 digits, okay? And page 10 to 19, right? And you all 99. Each time you use 2 digits. So how many integers there between 10 and 99? Between 10 and 99? 90, yeah. So 90 times 2 is 180. Okay? All right. So now, page N, page 100 to page N. Okay? The number of pages here is going to be N minus 99, right? And each time you use 3 digits, right? When you type the page number times 3. Okay? So this is where we find the formula. And total will be the total number of digits used is going to be D equals 9 plus 180 plus N minus 99 times 3. Okay, let's simplify it a little bit, right? It's 189 plus 3 N minus 3 times 99. So what do we get after you simplify? Yeah, 399 times 3, 297. All right, so that's minus 189. So you will get 801. So very strange number, 108. 108 is 108. No, this number is very special number. Right? So this is a formula. If you know the page number, you can get the total number of the digits you used. Okay. Okay, so next one. So number 12 can be written as the sum of 8 consecutive integers. Okay. What is the product of these integers? All right, so please do this problem. So you have the number can be written as the sum of 8 consecutive integers. Wow. What is the product of this integers? This is a little bit tricky problem. Mm-hmm. Okay. So how do you do that? You have 8 consecutive integers, right? You can write begin from bigger the first one, right, or from the negative. So this n and n plus 1, n plus 2, all the way to n plus 7. When you add them together, it will be 8n plus 1 plus 2 plus 3, all the way to 7, right? So this is going to be 8n plus 8 times 7 divided by 2. Yeah, divided by 2. So it's 28. So it's going to be 8n plus 28, which is going to be 12. So 8n equals 12 minus 28, and it's going to be negative 16. So n is going to be negative 2. So the first one is negative 2. The second one is negative 1. The third one is 0. So n plus 2 is 0. That's why the product is 0. Okay? My last question is, if two positive integers n m satisfies this equation, satisfies this equation as 31. Okay, find the n and the n. Okay, please do this problem. Right, good. I'm getting answer from here.
M squared.
Yeah, m squared minus n squared minus m squared. Who can do it? Brian, do you have answer? Edward. Okay, Edward is good. Yeah. Okay. So how do we do that? When you see n squared minus m squared, you should see that this is going to be product. Okay. But on the other hand, 31 is a prime number. You cannot express as a product, right? But the only way you can do is going to be 31 times 1. So then n plus m is going to 31, n minus m is 1. Right? So add them together, you got 2n equals 32, so n equals 16. Then you know, once you get the 1, you can get the other one, right? So m equals n minus 1, so 16 minus 1 is 15. So you got two answers. What's going on here? Okay, so you get this answers. So when you see n squared minus m squared, the first thing comes to your mind is you're going to factor it. It's n minus m and n time plus it. But on the other hand, you know, we already did a similar problems. You know, the trick is prime number can be only written as the number itself times 1. Then you actually get 3 equations instead of 1. Once you have 3 equations, you can uniquely determine n and the n. Okay. Now my question: are you doing the homework? Because I don't get to see your homework, and I just trust you. You're doing the homework. When you do the homework, here I have to repeat again. You know, if your parents already check your homework, that's fine. I'm okay. The point is, when you do the homework, I don't want to see the answer only. I already give the answer. Okay, I'll repeat again. I already gave the answer. I want to see you show the work like what I did in the class. Okay, you needed to work on a separate page, you know, wide little page, okay, and then show. You don't need to copy the problem, but it shows the details step by step, so your parents can see whether it's correct or not. If the answer is wrong, they can find out where's the mistake. Okay. So this serves the third purpose of to study here. The third purpose, I repeat again, to learn express mathematics in the correct way. Okay, don't treat your homework in a page like a scratch paper. You know, okay. You don't need to circle the answer because the answer is always at the end of the solution, so it's clear to everybody. Okay, so you have to show step by step like what I did in class. If you don't know how to do it, okay, and that's it. And if you want to turn in the homework, I checked that for you. Okay, that's fine.